Stamitalks.
All right, welcome everybody to a new episode of Stamitalks. Not just today, we're always talking about fertilizer technology, and today we're going to talk about Stamicarbon equipment in non-Stamicarbon plants. It's a big mouthful, but to guide us through this topic, we have our senior mechanical engineer, DJ Kroijmans. Welcome, DJ.
Thank you.
How are you doing?
Fine, always. Thank you, Mark.
Okay, well, so DJ, you joined Stamicarbon in 2018.
Yeah, correct.
What did you do before you became a senior mechanical engineer at Stamicarbon?
Yeah, so I joined Stamicarbon in 2018. Before that, I worked for many years in a pressure vessel equipment manufacturer, basically doing the design of these vessels, discussing with clients about their specifications, finding out what they needed, and transferring that into actual design drawings.
Okay, and in terms of your activity now in Stamicarbon, just for normal Stamicarbon equipment, you are mostly involved as senior mechanical engineer in designing vessels?
Yeah, so right now I work in the services department, the advanced department as we call it. I'm doing the mechanical projects of the equipment replacements. Okay. And in those projects, I'm basically the link between the client, the actual manufacturer, the process engineer within Stamicarbon. So I build the specifications for the vessel, the data sheets, and then I follow up on the project when it's in production.
Okay, so then you are indeed the right person to talk to, because then you're involved in many different parts of the process and acting as linking pin between them.
Correct.
Okay, all right. So then that's of course all for Stamicarbon equipment in Stamicarbon plants.
Yeah.
But then today's topic is about Stamicarbon equipment in non-Stamicarbon plants. So maybe to start off, why would you do that? What's the difference?
Well, the working in Stamicarbon plants is of course the easiest, because we got everything worked out. We got standard data sheets available. We have the whole process figured out. So it's a little bit more the standard way of working. It actually gets interesting when you work into non-Stamicarbon plants, because then you don't have that whole design philosophy available, that whole background. So you actually have to talk a lot more with the clients. What do they want? Figure out what their restrictions are. There's often a visit to the site involved to see the space available, because again, with the Stamicarbon plant, we got all the information in our databases, and I can just look in our system and find almost everything I need. In those situations, it's much more interactive and much more challenging.
Okay. And what do you mean exactly with design philosophy?
Well, we have a very strict set of design rules for our equipment, and when we follow that, we know exactly that the output will work. When you work with a competitor plant, you often have to look at the drawings, have an interaction with our own process engineers to figure out, why is this here, why is this there, what can I modify, what does need to stay the same, both from a process and from a mechanical perspective.
Okay, and you say I want to modify, or maybe can I modify certain elements? Why would you want to do it? Why not just go for a one-on-one replacement?
Yeah, I'd say when you replace a vessel, it's had quite the life, and it's also had a long operational experience. So people know what they liked about the vessel. They also know what they didn't like about the vessel.
Okay.
So
like
things that break down,
okay.
Things that need repairs, corrosion problems in an unexpected spot. The plant probably works at a much higher capacity than it worked when it was originally built.
Okay,
you see that in all plants, and then
because
making simple
because the material gets thinner during its lifetime. Is that the reason why the capacity increases, or does it have other causes?
It can have multiple causes. A typical example you give indeed is when a heat exchanger, contradictionally, it's not what you'd expect, but it starts performing better the more it corrodes, because you get much more efficient heat transfer. And then when you replace a heat exchanger in a plant, you have to take into account that if you replace it with the original one, the plant capacity might go down. And I'm pretty sure no plant manager would love that. So those things you have to take into consideration for sure.
Okay, so then why is to basically improve the plant, but then still you could go to the original licensor and say, can you give me new whatever type of equipment you want to replace.
You could definitely do that. I think there are a few reasons why sometimes we are, or often we are contacted. Could be that the original licensor is no longer available. And it's also something that I often hear when talking to clients, that we are quite unique in the fact that we try to offer that total life cycle support.
Okay.
So the presence of the Stamicarbon Advanced team, I think, really is a help to clients, that we're always available for small and large questions.
Okay. So full life cycle support is basically then from building a grassroots new plant to get services, and then possibly even evolving it and upgrading, revamping the plant. So
yeah. And what you often see is that everybody is interested in selling a license, of course, because that's the majority of what we're doing. But at the same time, we learn a lot from doing the services, by going into the plants, by doing plant inspections, talking with the clients. Yeah.
Okay. So replacing it, I think, is one, from a client's perspective, makes sense.
Yeah.
But then going to Stamicarbon, because then you get this extra process knowledge and you get extra support in this, well, mostly upgraded equipment.
Yeah, correct. I mean, you can take your original drawings, if they're still readable, you can go to an equipment manufacturer, you can have them manufactured, but you don't know if it's going to be built according to the philosophy of the vessel. Minor changes may have a big impact. In the case of urea, for instance, the corrosion is a big problem, so our knowledge in the welding processes helps a lot in the material selection. So that gives the client the assurance that the vessel that will be delivered will have a long lifetime ahead.
Okay.
And that's a trade-off. That's a choice they have to make. Yeah.
Okay. So then I think also if you would acquire this via Stamicarbon, then you would have this, not just the equipment manufacturer, but also the inspection services to make sure that the equipment meets specifications.
Exactly. So you have the vessel delivered that you always have, but you also know you have a process engineer on the background that looks at it for you. You have a mechanical engineer that follows up the drawings and everything. We have an inspection department that follows up with the constructions of the vessel. So they go into the shops, actually inspect during the welding and in intermediate steps.
Okay, so they have hold and witness points to check the quality.
Yes, we put the hold points always in positions that we are sure that we inspect the things before they become unrepairable. Okay. And that helps a lot. After that, also on the site, if the client wants to, we can help them with installation services, site services, inspections in a later stage. Yeah.
Okay, so that I think basically covers why do you want this.
Yeah.
Then next question, of course, logical would be to know how do you do that, because there are many different types of, I think mostly it would be high pressure equipment.
Yeah.
Many different type of licenses, several different processes, different types of equipment. Are there pieces of equipment that would stand out more?
I think, if you look, at least in the urea business, it's always the same type of equipment you encounter. So strippers are the most common equipments that need replacements. They have the harshest conditions in the process, so we know their lifetime is limited. So yeah, strippers for sure. And that brings us to, in this case, then the thermal strippers, because Stamicarbon has its CO2 stripping process, which works a little bit differently. We did a lot of research into making sure that we can also offer a good solution for thermal stripping plants.
Okay.
Another equipment that we see from time to time is the kettle type condensers, which also have their own failure mechanisms, where we think we have a good solution.
Okay. Now, what's a different failure mechanism compared to normal Stamicarbon equipment?
What you see is if it's constructed from BCO5 material, you always have corrosion in the top rows of the U-bundle, and you also have some corrosion on the tube ends, and those things don't occur when you go to a duplex material.
Okay. So you say, well, we've seen this before. Do you have an example? I'm assuming you have experience with a kettle type condenser then?
I think I was involved in a project a few years ago. let's say it happened right around when COVID hit.
Oh, okay.
So that became a very interesting project. So
Additional dynamics.
additional dynamics, indeed, a lot of late night meetings via Teams, which was something everybody was still getting used to. So that was fond memories of of those meetings. In that case, we also the contract was signed. The client was happy that he had a solution, and it started with some process optimizations that we had in the contract. But once the project started running, there was this whole new wish list that popped up, like the project team formed at the client location, and people started, hey, but we also had this problem at that time. Is that something you can look at? And I think in the end, we ended up with a vessel with a lot more heat exchanging areas. We had to move a lot of the nozzles. The partition plates between the inlet and the outlet were completely modified. We switched materials. So
Okay.
yeah.
So then I think the key question to ask is the client happy? Because you made a lot of changes. Because I think that this sounds like a extensive project to, well, if you would minimize this, it would be just replacing a condenser. Well, it became really an upgrade.
Yeah, I think when you replace a vessel, you always have two options. The easiest is to do a one-on-one replacement. Let me say that a one-on-one does not exist when you replace a vessel, because there's always something that changes in the meantime. But you stick with the original design. But this was a really nice example of where you actually help the client, I think, with a lot of the problems they faced. Process-wise, we do have the confirmation that the client is very happy. They really see a difference in operations before and after.
In terms of consistency, or what has changed?
The process efficiency.
Okay.
So the process just runs a lot more efficient now.
Okay.
When it comes to the mechanical aspects, of course, we'll have to wait a bit longer. The vessel is in operation now, I think, for a year or two. So we're still waiting for the first inspection we get to do.
Okay.
But we're confident that will work out nice.
Hopeful outcome. Okay.
Yep.
So it's thermal strippers, it's kettle type condensers.
Yep.
Are we talking about other equipment as well?
Yeah, we've also been involved in reactors from time to time. Reactors are a little bit, say, the easier vessels in the urea process, if you ask me from a mechanical point of view.
Yeah.
But they also have a much longer lifetime. So that leads to the situation that everything I explained before is even more applicable. Technologies have changed. Plants are often already very old by the time the reactors break down. That leaves us also there with quite some possibilities.
Okay, so there you can also provide this supportive service and possibly upgrade also. Well, almost guaranteed upgrades what I hear you say.
Exactly. You can change the internals, the trays for a more efficient configuration, but you can also increase the volume. But also, and that's what you see a lot with a reactor, it's not a vessel client really likes to change, so they often try to repair it as long as they can.
Yeah.
And also there we've seen some interesting projects. Yeah.
Okay, and then in terms of you can, if everything is on the table, you can change the design. I think you can also change materials. Is there any limitation? Could you take a competitor process and just change the material, or are there limitations in essence?
I'd say there are for sure limitations, but they're based on the project. So you have to talk with the client. First limitations are their actual plant, because you can build a reactor that's 4 times the size, but it will not necessarily be cost efficient change.
You can build a skyscraper and
exactly. So it has to fit in their plans. It has to make sense, and that's again the process in the interaction between client, process engineering, and mechanical engineering. You can change the materials also to ensure a longer lifetime, which is of course always an advantage. And in some cases, we've seen situations as well where other restrictions are in place, and then maybe a reactor breaks down and there is no time to replace it, and they go for a repair. But of course, when you repair a vessel, you also take away the need to replace it. So it might not be the economical decision to repair a vessel at one point, but if you have to choose between shutting down your plant for a year or
Yeah, it can be a bridging solution to buy some more time to...
Exactly, and that bridging solution can, unfortunately for us, also become permanent from time to
Okay.
time.
So in terms of the let's say creating the bridge, how, because as you said in the beginning, these processes are more complex than, let's say, a Stamicarbon equipment in a Stamicarbon plant. Does this typically take longer to develop, or is the, let's say, the lead time of such projects more or less the same?
I think the lead time for the project is not impacted. It's the dynamics in the acquisition phase that are different. I often see much more involvement from a process engineer. Often they go for a planned assessment, have a look at how it's running. It takes a bit longer to find the required documents.
Yeah,
also at the client side, it can take a lot of magnifying glasses to actually try to read the drawings.
To read all paperwork.
More than enough examples where some critical dimensions were not available, and that means somebody has to calculate them, and we have to make sure that it still functions. Yeah.
Okay. Oh, interesting. And then, well, I think so far mostly we've been talking about urea-related processes.
Yeah.
What does the future hold? Where does this whole development of non-Stamicarbon plant services go to?
Yeah, I think historically, if you look at what we've done, urea has been our main focus in the last years. But as we're also evolving into different processes like nitric acid and the ammonia developments, of course, we're also looking at the same equipments and the same services in all other.
So you can look at ammonia converters or tertiary abatement reactors for nitric acid. Okay.
Exactly.
Oh, that's very interesting.
Yeah.
Any last thoughts from your side before we close this podcast?
Last words? No, I hope to get more of these challenges in the future because
I can imagine that as an engineer, these are fun projects to work on.
Exactly, they stay top on your mind even years after you've completed them. Yeah,
I can imagine. Well, thanks for explaining, and I hope this to some extent contributes to more exciting projects for your work, DJ.
For sure.
Okay, thank you.
Thank you.
And also thank you to our listeners to Stamitalks, the fertilizer technology podcast.
Stamitalks.